Hello and welcome to episode 4 of our awesome series on web services. So we are now going to talk about some ideas about, well, the first idea I want to put on the table is a savings habit. Well, a saving habit. When do you save? Web services are the means by which a front end deals with a system, right? A system is running on servers, the front end is running in the browser, it talks to the servers through web services. Which means when the front end of your application is showing a large form and users are typing in data, at some point the data needs to be saved. So when do you save? When does the front end talk to the server side code through a web service call and asks it to save data? The classic forms that we used to build 30 years ago and which people are building even today will have a long form, usually ugly, with a save button at the end or submit button at the end, bottom right hand corner. So the user is expected to keep on filling all the details in all the fields in good faith, very little interaction, and at the end when he clicks the submit button, the data is taken in one big chunk, sent to the server in a web service call, and the server sends back all sorts of errors. That is the classic and relatively less user-friendly approach to saving data. Now, there are other ways to do it. One of the common examples we see, which most of us probably have seen already, because most of us are users of Google interfaces and Google portals, is when you edit a calendar entry in Google, right? You go from one field to the next, but as your cursor moves from, let us say, the email address field to the telephone number field, the email address gets saved. So when you are editing an existing record in Google Contacts, movement of your cursor from the focus, from the current field to the next field, triggers an invisible implicit saving of data. So the save on move focus is another approach to saving, which is very different from the submit button. You have to decide what is better for you, but the web service call changes depending upon what the UX team decides is the right UX for your application. Then there is the autosave. Many applications provide you an autosave facility where as you type, your data gets saved periodically, typically when there is a lull in the keyboard. So there is any idle time in the keyboard, that idle time is identified and a save push is attempted to save the half complete data on the server side. So autosave has various angles or various questions to be answered. One of them is this autosave going to be treated as equivalent to a proper save in the proper table? Or is it going to be treated as temporary scratch pad data to be saved in some location on the server, but that location is not the final location? So these are decisions you have to take in your web service, depending upon the strategy you wish to follow. Then there is another type of save, which is given in some applications. We've done it in some of the applications our teams have built, where the user sees a very large form and it can take the user more than a day to fill that form. Especially, a purchase order or a sales order can have literally hundreds of line items. So the user fills the form slowly and takes time to fill the form. And he often needs to suspend his work, go somewhere else, look up something else, check some data, verify something with somebody, come back and continue filling the form. So in this type of scenario, we often provide a separate button called Save Draft, where you just save whatever you've edited. It is not auto save. It is not field by field save. It is not the final submit button. It is a save draft. So the save draft is well understood that it is going to be saved in a temporary workspace. The user can log out and come back tomorrow and log in, and he can resume editing or filling the form which he left today. So there is clear continuity and clear assurance of work protection, half-complete work protection, but it is not a final submission. So The save half complete is a very interesting and valuable feature, especially for very large forms. So even for save half complete, you have to decide, do you want to do an auto save or do you want to do an explicit save with a button? So both can work. It is important to understand that any implicit save must not do strict error checking. The idea is that I am typing data into one long form, I am at my wit's end, I will be making mistakes, but I am not doing the final submit. I am not formally submitting the data to the system. So why should the system keep complaining about this not being correct and that field is mandatory and it must be filled and so on and so forth. So error checking needs to be suppressed for auto saves. Even for half complete saves where I am saving a draft of my form, the error checking should be suppressed. It does not have to be 0, but it has to be near 0. The idea being the user is expected to correct all his errors before he does a final submission. You must give him the chance to work on his form and submit data only, and only then take responsibility for the correctness of the data. Don't pester him with error messages when he himself has not indicated that his data is error free. So error handling in different saving strategies need to be different. Web services need to be designed appropriately. Database tables need to be provisioned for these things. For instance, for a half complete record, for saving of a draft, you may have a separate table completely. You may not want to keep half complete drafts in the same table as your main final and verified records. So all of these things need to be taken cognizance of depending upon the UX that you wish to offer the customer and the customer's business requirements. So these will impact your saving of data web services. So we talked about the error handling having to be different if you're doing auto save and implicit saves and saving of drafts, etc., right? And we've also, I mentioned that sometimes we need to do additional tables, separate tables for storing the drafts, which should not pollute your main table because it makes querying easier. You usually are processing only those records which are not draft. So if you are not storing the draft in the same table, you don't have to add a filter condition for every SQL statement which later on comes and processes the data. And one of the important things to understand for project planning is that these things can increase your software complexity and overall function point count of the amount of effort required to develop the application. So a simple screen which just has that boring old submit button at the bottom right will be developed with much less effort than a more user-friendly screen which will have intermediate saves, it will have intermediate error checking and so on and so forth. So we need to take cognizance of this and freeze all these details before we decide the work breakdown structure and the effort estimate for the development activity. So make sure that these are not thrown in as afterthoughts, because if they are, they will derail your project timeliness and time tracking for your delivery. Now there is this point which is a little bit of a pain point which I have usually emphasized over and over again to the technical leads and the dev teams which have worked with me. There is this strange belief that web services are designed to fit a UI. So if a UI has 20 fields, then the dev team which is developing the UI expects to be given a web service which will return exactly those 20 fields. And when the data is returned, the UI team expects that the names of the fields in the JSON data structure of the response will match the names of the fields they are using in the JavaScript for the UI. It is pretty unnecessary and pretty absurd, but this is the kind of expectation that is there. The teams which develop UIs, develop front-end code, seem to have this blind belief that the web service data structure and field names exactly must match the UI. This is absolutely unnecessary. It is a very important step that web service designers need to design web services to be flexible and to be independent of the details of a specific UI. Today, if there are 20 fields, tomorrow if there are 22, ideally the web service shouldn't need to change. The web services as a group need to provide flexibility for the front end to be able to pull out 20 fields if they want 20 and to pull out 22 fields if they want 22. So it is important to disconnect the web service from the bits and bytes details of the fields, of the layout, of the structure of the front end. Okay? So this is a very important discipline. Now there are certain situations where the UI, the web service has to be designed or specified based on the front end. So these are the rare situations where I recommend the opposite. So what are those two situations? One is the get calls. Basically, when you are loading a big record from the server side, the get call which is web service which is used, it needs to be customized to the screen for two situations. One is when there is an edit or an update screen with lots of fields. So if you have a very complex field which has a very complex screen form which has lots of fields, and those fields are partly from one object, partly from a second, partly from a third, then it is better that you do a full tree get. Full tree traversal get call, a single get call which traverses the database, pulls out data from various object classes and gives you a single big JSON data structure which sort of fulfills your entire screen's requirement. So this is one situation where it might be useful to build a get call which matches the screen, instead of having 4 different fragmented get calls where the front end is forced to make multiple get calls to load parts of his screen one by one, because that way the performance really gets killed. The loading performance goes into a terrible state. So that is one situation where the get call may have to be designed for a particular complicated screen. The second situation where this is required is for dashboards. A dashboard by definition requires to show lots of data from lots of different parts of the application. If you use the classical web services which are being designed by the server-side team who are unaware of your dashboard, then they will be giving you a bunch of separate web services, and the dashboard will probably need to make 20 web service calls to load all the data it needs. This is another situation where a single dashboard specific get web service can really speed up the data loading. So these are the two situations where you do a screen driven web service design. Okay. So the important thing in these situations is that you try to have one single web service. The front end should be able to make one single web service and load all the data it needs. So in the interests of that speed, it is important sometimes to build a custom get call. Now, sometimes it is possible to not have to write the code for custom get call. Sometimes it is possible to use an API gateway to do this aggregation. So the API gateway can be configured that when a particular call comes to it, it will not pass the call to the server. It will internally make 5 different get calls, pull in the data, aggregate the 5 different blocks of data into a single JSON and return it to the caller. So this is very possible with modern API gateways, and this might be a good way to do it rather than actually writing another get call to query all sorts of tables and pull out data. So the important reason to do this is latency of the loading. The loading activity should not take a minute, even if you are loading 100 different data points. So this is one situation where web services may need to be designed keeping the screen in mind. The reverse of this screen-driven get is a screen-driven save. What this means is, I'll give you an example of a very common situation where this happens. I'm entering a purchase order or a sales order or an invoice. Now, if you look at an invoice, there is some master data at the top, which talks about the counterparties, the date of the invoice, this, that, etc. And then there are line items. Now, if there are 40 line items and you have one save call to save the invoice master, and then you have 40 line items to be saved to an invoice details or a purchase order details table, you have two tables, you have two web services, one to save the invoice master data, one to save the 40 line items data. Then in the worst case, it is possible that your invoice line item saving web service only saves one line. So if you have 40 line items in your invoice, you might need to do 40 calls to save 40 line items and one call to save the master. So 41 calls to save an invoice. So that is a really, really ugly situation. That save will take forever. So the next best thing which we see sometimes happening is there is one web service to save the invoice master data, another web service to save an array of 40 invoice line items to the invoice details table. So we have, from 41 we have come down to 2. I would say in such situations, it is better to have one web service, which will save the master and save the line items all in one shot. Internally, the data will go to different tables, but the web service will be only one, and there will be one web service call. So the latency really improves, performance really shoots up, and you get a tighter transaction management, because the master data and the line item data can all be inserted into the table under the encapsulation of one transaction. So you get better, transaction correctness. The all or nothing functionality that we all look for is easier to achieve if all of this is done using one web service. So this is an important situation where you need to rethink your web service design or specification. The boundary of your web service needs to be designed based on what is happening on the screen. So these are two situations where I'm breaking my own rule. Now we move to a completely different topic, SQL. Okay, so there are various reasons to worry about SQL. The first problem is that, at least in the ecosystem where we work, developers who write reasonably competent web service code are relatively less competent in SQL. So it is important to separate out the SQL statement from the rest of the web service code and make sure that there is a certain degree of supervision brought in to get your SQL statements right. See, we have seen pathological cases where what could have been pulled out from a table or a set of tables using one complicated SQL statement with joins was being pulled out by making a first SQL select statement on one table and then looping through the record, the result set of that first SQL select to make SQL statements, select statements on a second table. So if the code was interested in pulling out 100 records in this composite situation of two tables, it was actually making 101 select statements. So one select statement on table 1 followed by 100 select statements on table 2. So this kind of pathological code exists in the industry. It doesn't get caught during testing. It only cripples your reports when it is being run with a large data set. So in the functional testing, at the first level testing, the performance is not noticed, but the code is terrible. So it is important that if you wish to neutralize this danger, then bring in a certain level of oversight into your SQL statements separately from the rest of the code, and that can only be done if the SQL statements are in a separate constants file. So that is why we have one of our 5 dictionaries as the SQL statements dictionary. One of the beautiful things about developing web services, business applications in Go is that Go In the Go ecosystem, there is a tool called SQL-C. SQL-C allows us to define the SQL statements in a particular file, and then it generates code for each of the statements. So that automatically takes away a lot of the headache of writing SQL interface code in the programming language of your choice, and it also, as a side effect, gets all your SQL statements in one place. So it's a very convenient and powerful addition to the Go programmers' arsenal when we are developing business applications using Go. Now there are difficulties which are not very easy to address, which even SQL-C does not address, or you have to choose other tools. When we have a flexible and powerful web service where the filter parameters are optional, then we have a variable where clauses in the select statement. Because if I am calling the web service for a list call, I am calling the web service giving one filter parameter, then the SQL statement ideally should have one where clause in the in its body, in the SQL statement. If I am making the same web service call a little later with 5 filter parameters, then the where clause should have all 5 of them. So the where clause changes, which means the SQL statement is not constant. It will change from call to call. Similarly, when you are updating things, if there is an update web service, today the update web service is being called passing one attribute and new value. Tomorrow the update web service will be called passing 3 attributes and their values. So the update statement, the set clause of the update statement will need to change. So the SQL statement becomes dynamic even there. Then when you are using the fields parameter in the list call, I want only these 5 fields. Then the variable set of column names go into the select statement. So in these situations, it is a challenge to write easy code, easy readable code to handle all this, because here you are forced to handle the dynamic nature of the web service, which then mirrors in the dynamic construction of the SQL statement. So we need to address this problem, and different programming languages, different programming frameworks have different tools to address this. But it is important that the web service designer understands this challenge and then selects the right tools to handle it. In some situations, the good option may be to use an ORM. The ORM might hide some of these complexities of raw SQL below the ORM layer. So pick ORM with care. We recommend not using ORMs blindly because they have other problems. But in this particular situations, ORMs might be the solution that we need. So we come to the end of episode 4. Thank you for watching. It's been fun so far, and we are looking forward to having you again when we start episode 5. Have fun. Thank you.